Hi everyone, my name is Raghu and today I'll be presenting a generative AI application that I've built for ArangoDB Hackathon called smartFly. So it is a simple AI powered travel assistant, and before we get into the functionality of this application, I would like to introduce myself and then move on with the motivation. So my name is Raghu and I did my master's in computer science from University of Ulm in Germany, and I'm currently working as a research assistant. And my main motivation to participate in this hackathon is to get hands-on experience on the latest technologies such as GraphRag and CuGraph. So I've built an application called smartFly. So smartFly is a simple chat application that assists users with flight as well as airport related queries. So I think the definition is pretty simple. So the interface of this application looks as shown on the right hand side of the slide. So we have the query, so which is the input, and the smartfly application generates a suitable response by making use of GraphRag, and the particular output is then displayed to the user. So in comparison with the other application, so the smart fly application is pretty simple to use. It is a simple chat interface, and the results are more accurate because of the use of GraphRag, and the hallucinations are minimized, and also the accuracy is better compared to the other applications that we already have in the market. So for in order to build this particular application, we have to make use of a data set. So for that, I've made use of this data set called flights from that is already there in ArangoDB. So the properties of this data set has that it has 3,375 nodes and 2,86,463 edges. So the graph is as shown on the right hand side. So the steps that we have to follow to build the application is as follows. We choose a data set, we load it on the network X, and we persist onto the ArangoDB, and then we build the application on top of it. However, since I'm already using a graph that is already there in the ArangoDB, steps 1 and 2 are not required. So all we have to do is to build a application on top of ArangoDB. So we'll see how this application works. For that, uh, this is my notebook. It's called smartFly Final, and this is available on the GitHub, and it is made public. And since we are making use of NVIDIA cuGraph, so it is important to change the runtime, and the runtime should be a GPU. So the hardware basically should be a GPU, and then we save it. And here in the beginning of the notepad, I have explained the overview of the application and also the architecture of the application. And in the first few steps, what we are doing is we are installing all the necessary packages that are needed to run the applications, starting with ArangoDB NetworkX package. So then we check if NVIDIA GPU is available. So by using these two particular commands, so once this is done, we install the NetworkX cuGraph, and so likewise we also install all the other packages that are needed to run the application. One important thing is that since we are already using the graph that is already present in ArangoDB, we also have to install this particular Arango datasets. So once all these steps are followed, the next thing is to connect to the ArangoDB, so which is done here. And the only thing that needs to be changed here is the username and password. And then all these lines of code are basically used for debugging and to analyze the graph that is present in the ArangoDB. So here I'm printing the edges and the nodes of this particular graph. And now we have in this section, what I'm doing is to analyze the graph using different techniques. We have many techniques. So one technique is the called graph history. So this gives a more uh, colorful representation of the nodes and edges, and you can see on the right hand side we also have the detailed information about the latitude, the longitude, and also things like the country and so on. We can also see the number of nodes and edges that this graph supports. So the other way to plot the graph is by using NetworkX library. So, and this is how the graph looks like. And then once that is done, what we have to do is reconnect to the graph. So for this, we can simply do that by using the function uh, digraph. So this is basically a directed graph. So instead of this, we can also make use of a multigraph. So with multigraph, it supports more complex queries, but for this demo, I'm just making use of a simple direct graph. So after that, it is essential to wrap the or create the Arango graph wrapper. So by using this particular code, and here I'm printing the graph schema, and now that is done. So I'm adding a simple AQL query for debugging purpose to find the busiest airport in USA and printing the output that we get. And the other query that I'm using is to execute or to find out the airport with the most international flights, and I'm also printing the output. So these two steps can be skipped. So that's only for debugging purpose. And I'm making use of LLM agent, which is from OpenAI. So for that, the essential step is to import the secret keys. So this is what is done here. And now comes the main part of the application, that is to define the tools that is required to build the application. So what there are a bunch of tools that I've used, starting with a welcome message. So this is to send the user with a simple hi, how are you message. So as soon as the user logs into the application, and there is another application, there is another tool called as app info, and this particular tool is used to define the functionality of this application. And the third tool that I'm using is the text to AQL tool. So this particular tool is responsible to handle simple queries by converting the natural language into AQL, executing it, and then converting the results back into natural language. So complex queries and hybrid queries are not handled by this particular tool. And then we have other tool which is used to handle the complex queries. So here what happens is the network X algorithm that is best suited to execute the complex query is invoked, it is executed, and the result is converted into a natural language, and it's sent to the user. So the main part of this application is to handle hybrid queries. Sorry. So hybrid queries are nothing but queries that are a combination of simple as well as complex queries. So the logic that I have used to handle this hybrid scenario is to split the query into simple as well as complex query. So I've made use of LLM, and then from the incoming query, I have separated the simple part, and I have also separated the parts that needs to be executed by using NetworkX algorithm. So the part that has to be that can be executed using AQL object is first executed. So with this particular piece of code here, so if AQL part is present, so I'm invoking the AQL object and then executing the simple part of the query. And to handle the complex part of the query, what is being done is we make use of the network X algorithm, like in the as described in the previous few minutes back. So after that, what I'm doing is I'm combining both these results and printing a consolidated short and a clear answer to the original query, and this is then sent to the calling function. And the other important aspect is the support of multimodality in ArangoDB. So there are multiple functionalities that ArangoDB supports, and one functionality is called the Arango search. So Arango search is a full text search operation, so that makes use of text-based searches based on keywords and phrases and so on. So this is how it is done. So one important thing is here to set the search view. So this search view can be set from the ArangoDB web interface. You just have to log in to the ArangoDB client, select. We have to create view, and this is the view I have created, and then I have linked the collections to it. So, and after which you can see this particular configuration on the right hand side. We have to save the view, and this particular view has to be copied in the code here. And this is the function that is used to invoke the particular tool based on the uh, complexity of the query. So be it like simple or complex or hybrid and so on. So this particular create tool calling agent is responsible to call the appropriate tool. So here I've listed a bunch of queries that can be handled or that can be used in this particular program. So let's see with some simple queries. So my first query is to find the busiest airport in US. So since this is a simple query, the tool that is getting invoked is text to AQL to text. And the output is displayed. So let's see some other queries. So this is a query which is complex. So the query is how can I travel from one airport to the other? I'll execute this query, and the tool that gets invoked is the one that is responsible for handling the network X algorithm. So the network X algorithm gets executed, and the result is then generated back into natural language, and the output is displayed. So now we'll see a hybrid query. So this is a combination of a simple query and a complex query. So the simple query, as you can see, now the tool that is called is text to hybrid to text. So the tool is basically responsible for identifying the part of the query that can be handled by invoking the AQL object, so which is this one, and after which the network X algorithm is called for the complex part, and both these results are then combined to generate a suitable output. We'll also see some other queries. So this is also another example of a hybrid query. So the query is that which is the best route from JFK to the most popular destination in USA. So again we are making use of the AQL, and here also invoking the network X algorithm, and the final answer or the final response is generated by combining both of these results. So now we'll see one more application. So as I mentioned about Aranga search, so to make use of Aranga search, we'll make a query something like this. So it is find flights with flight number 579. So as you can see, the application that is or the tool that is called as text to Aranga search AQL to text, and then it generates the necessary response based on that. So we can see a few other examples. So for example, I have made a note of the queries that can be done. So this is again a simple query wherein we want a list of all the airports in USA, and the tool that is getting called is text to AQL, and then the AQL request is executed and the response is converted into natural language, and it's displayed. So this is yet another application wherein the query is to find the flights arriving at Chicago. So here we have the keyword and sorted by arrival time. So since we have the keyword mentioned here, so the tool that gets called is the text to Aranga search AQL to text, and then it displays all the details corresponding to the query. And we have some other queries as well. And besides that, we have also implemented the uh, Gradio application, which also works. And thank you.